So in my the test here that I want to do to the audience, hopefully you will be able to give me some answers to the questions here, is we have a new cable with 50 terabits. It has 10 terabits in year one that's lit. Demand's growing 35% per year. How many years until the cable is 10% full? Is it 3, 6, or 10? Yell out your answer. 0 years, okay. 0 years. Anybody have an idea here? Elaine, how many years? John? Valley, you know this. Valley knows the answer to this question. Okay. The answer to the question is 6 years. No one wanted to say because they don't know. People are confused by exponential growth. It's just 6 years to reach the level of 10% full, okay? So the next question you can see here across the bottom of the axis here is, I want to ask you how many years until it's going to be 50% full. So it's 6 years just to get 10. So is it 9 years? Is it 12? Is it twice as long in terms of the amount of years? Or is it 20? Anybody have an idea? Oh, no. Everybody's too shy. The answer is 12. So it takes 6 more years to get that extra 40%. So we're roughly halfway full at roughly 12 years here in this example. So the last question is, though, how many years till the cable is full? It took us 12 years just to get halfway full. So will it take 14, 17, or 24 years? Who knows? A cable's lifespan, remember, it's 25 years, supposedly. So big surprise here. It's just 2 more years, roughly. 2 more years, and the cable is completely full. So it's kind of shocking when you think it's very lightly used for so many years, and then magically in the last part of the years here, it gets very full very quickly. So what does this mean for the submarine cable industry? So I think there's a few things that we can draw upon tied to the growth rates of exponential growth rates that are really important here. One is that cables may seem lightly used for many years in terms of how much of the capacity is lit and brought into service, right? But there's not an oversupply happening. That's just normal, right? But also, once cables have been in service for a while, and they have maybe some, what you think are modest fill rates, 30, 40, 50% of the capacity is used, that's still small, right? Well, maybe it's not, because if growth is rapid, which often it is, that cable could fill up very quickly, actually. So we need to bear that in mind. Also, long-term demand forecasts, they're uncertain. Growth is not 35% every single year on a constant rate. And small variances in growth rates, they can lead to sharply different outcomes in later years for a cable. Finally, we've just discussed demand here, but also it's worth bearing in mind that unit prices of bandwidth are also experiencing not exponential growth, but exponential decay, okay? So as we are expanding the supply, that lowers unit costs, which leads to lower capacity prices, as we all know. And so I think it's easy to underestimate just how low future capacity prices will be compared to current rates. So one last point on exponential growth is an experiment that I wanted to show you that was done in 1884 by a German psychologist called Hermann Ebbinghaus. And he demonstrated the exponential decay of knowledge retention. And so this chart that he has shows, which is called the Ebbinghaus forgetting curve. You can see here on the axis that memory retention on the y-axis from 0 to 100%, number of days at the bottom, 0 to 6. And so on day 0, when you learn something, you retain 100%. As each day goes along, you retain less and less of whatever it is that you've learned. So if whatever I've shown you here today is scary, is troubling, don't worry, because you'll soon forget all about it, okay? Thank you very much.